Welcome back. So last time we started with processing our data, finding the time for a length of paper to fall from our start time and stop time, so just looking at a subtraction. Then we found the average of our times for each trial, and we did that here. Then we found the maximum and minimum, so going back up, so we looked at the maximum time, the minimum time for each length, and put it right here so that we could then find the uncertainty and say max minus min divided by 2. All that was to figure out what the uncertainty was so that we know how big our error bars are going to be once we graph this. That's it for what we did last time. So we've found the fall time for each trial. So let me kind of gray that out. We averaged the times for for each length. So let me gray that out. We found the uncertainty in time and decided on the uncertainty. So the decision there was, are we going to use our maximum uncertainty or are we going to average them all? I tend to default towards maximum uncertainty, but you could also have averaged them. So what that would have looked like is taking all of these numbers, averaging them, and then using the average as the uncertainty. That is justifiable as well. You just explain which method you're choosing. All right, next we're going to graph and check to see if it needs to be linearized, and that'll open up a whole different set of things to do. So for graphing, I'm going to go down here. I'm going to find my average times. So this is the data I graph. I'm going to highlight it and go to Insert and Chart. Now Google's been doing this thing lately where sometimes it'll do a bar chart like this, but more often than not, what it does is when I try and do a scatter plot, it will not use column A as labels. So you'll see two sets of dots when you're supposed to just have one set of XY pairs. Usually what that means is it didn't recognize column A or whatever left column you used as your label for it. So I'm going to say check use column A as labels. Another thing to note is to remember that I highlighted both columns of data. You can't just highlight one column of data. It needs to be both. Okay. Since this isn't going to be the graph that goes into my final report, I'm just going to do the quick method through it, meaning I'm not going to worry too much about titles and other things. I'm just going to do enough so that I know what's going on, and then later I can add in any important things like proper titles, etc., which you should look on the slides for. So I'm just going to say insert title. For my chart title, for my horizontal axis, I'm going to go ahead and just quickly say that it's time in seconds. For my vertical axis, I'm going to say, oh, I got that backwards. My vertical axis is time in seconds. My horizontal axis is length in meters. Oh, I think I said centimeters for everything. It should actually be meters for everything. I forgot that I changed how I measured. So let me quickly go back. Okay, so we've got length. Let me change this last one. Okay. Graph. There we go. Okay, so now that I've got my axis labels there, we're going to fit a trend line to it. So I'm going to click on my data. Under series, I'm going to scroll down. I'm going to go ahead and fit in my error bars. Now Google does a default 10%. We want a constant 0.09, I think it was. Let me double check that. 0.009. Okay, so 0.009. Cool, so those are my error bars. Those are pretty small. Yours might be a little bit bigger if you weren't as precise with your data collection. Next thing I'm going to do, I'm going to fit a trend line. So first thing we do is we start by fitting a linear trend line. We can take a look at that and see a linear trend line does not go through all the data points or the error bars, which tells me I need to linearize my data. The other thing that tells me I need to linearize my data is that the data starts below the line, then goes above it, and then comes back below it, which shows kind of a characteristic arc like that. It could be arced the other way, so starting above, going below, and then going back above. But usually if it's consistent and not more of a random scatter, that's a sign that maybe you're fitting a trend line that isn't proper. We can do a quick double check to see what we think it's going to be. So I like to go to power series. And once I do that, I can say for the label, I can say use equation. And so it looks like we're right around a 0.5. So this looks like maybe a square root graph. So that tells me I'm going to either want to square root my time or square my time. It'll end up being squaring the time, but sometimes I don't remember, and so I know that I'll either do the root of it or I'll do the actual squaring. So that is our graph right there. I'm going to go back and put a linear one in here. So this is what I would put in my report. I would obviously insert a proper title and clean this up a little bit in terms of the labeling, etc. But I would put this in a report just to justify, since linear trend line didn't go through the data points in the error bars, that this justifies me linearizing data now. So again, this is important to justify the linearization process. I'm looking at this and saying in my report, the trend line doesn't go through the data points or the error bars, and therefore it is not a good fit. So that now justifies us looking at something more complicated than linear. Okay, so that's our graph. So now we need to linearize our data. So first thing I'm going to do is I'm going to go back to the top, and we're going to linearize our fall time. So to do that, first thing I need to do, actually I forgot to include the length in here. So let me say length, and meters, time 1, time 2, time 3. Okay, so I'm just bumping it over a column so that it doesn't all overlap, and also so then it lines up with stuff down below. Okay, so for the length, I'm not going to mess around with my X data for linearization. The reason why is because it spaces out the data weird on the x-axis. Also, I can't account for any horizontal error bars, so it's better not to mess around with that and instead to look at how uncertainty is handled on the y-axis. For me, for using Google Sheets. Now, if you are using Excel at home, you can choose to linearize via the x-axis if you want instead. Okay, so I'm just relisting the lengths here. So it's just equals and this length over there. For the times, I'm going to start with squaring. So I'm going to go ahead and put, well, actually, we'll start with square rooting. I'm going to go ahead and put a 0.5 so up here, just so that I remember it's to the 0.5 power. I'm going to go ahead and say equals. I'm going to click on this data over here. I'm going to say to the 0.5 power. And then I'm going to fill down. So we've now square rooted all of our times. I'm then going to do that again by filling across. So now we can double check that, yes, it did in fact take the square root of this time, and this one did in fact take the square root of this time. Okay, so next thing we're going to do is go down here, and we're going to now average those times. So I'm going to say equals. Notice that this is basically the same process as what we did before. We're just doing it with the linearized data. So we have that. I'm then going to say equals and average, and we are going to highlight those 3 data points. Now, the reason why I didn't just average my time from over here, or sorry, not average my time, square root or square my time from over here, is because we're going to want to do the max minus min over 2 again, so to figure out uncertainty, so that's why. So it's a little extra work in the beginning, but it saves us work in the long run. Okay, in case you forgot, I'm going to move this graph up. Okay, so what I'm doing for here is I'm going to say length in meters. I need to stop saying length in centimeters. I'm then going to say uncertainty. I'm going to put a little caret symbol so that I remember it's for power or for the linearized data. And then I'm going to say max and put that time, or say time, and then put a little caret symbol, and min time, and put a little caret symbol, just again so that I remember this is for my linearized data. You can say equals and go up here. So I'm moving a little quick on this. Feel free to to pause, go back, rewind. But really what I'm doing is just moving my length of data down here. Now I need to find my uncertainty. So for my maximum time, I'm going to say equals the max of, and I'm going to scroll up, and I'm going to find my data up here and say the max of this data. It says 0.2813. I'm going to scroll up and looks like 0.2813 is in fact the biggest. We should expect 0.2753 to be the smallest for the minimum. So equals min, and I'm going to scroll up and we're going to highlight that data right there. Cool. And looks like it found it. Now rather than redoing that over and over, I'm just going to fill down. So grabbing that blue square to fill down. Okay, so for the uncertainty, it's going to equal the maximum. Oh, I need to include my parentheses. I always forget that. It's going to include my maximum minus my minimum. Oh, I can't write minimum. I have to actually click on it. There we go. All right, and then divide by 2. I usually like to go and double check this on a calculator, just because this is where some errors can happen, and these numbers are small enough and similar enough to each other that I'm not necessarily keeping track of everything. I'm also going to reduce my number of decimals so that it's a little less overwhelming. We'll leave it at that for now. I would need to go back and double check how many proper sig figs it is to have. But for now, I'm going to leave it like this, just so I can see a few of them. I can tell which data point's what. There's some differences between them, etc. But it's not an overwhelming number of numbers. Okay, so looking at this, it looks like my uncertainty for the biggest value is 0.074. So I'm going to say 0.0074 as my uncertainty, just so that I remember. Okay, next thing I'm going to do, I'm going to graph. Highlight my data. I'm going to insert chart. I'm then going to go to customize. Oops, sorry, it's chart setup. I'm then going to go to scatter. It looks like it recognizes as a single data set. I'm going to go to customize. I'm going to put in temporary titles, so chart title, insert title. I'm going to change horizontal axis to length in meters, and I'm going to change vertical axis to time. I'm going to put the caret symbol. Now in the future, I'm going to want to go back and say to what power it is, whether it's the 0.5 power or the second power or the third power or whatever it is. But for now, I'm just going to put the caret symbol and then I'll put a slash, and that'll remind me to do my units later. We'll underscore so that I remember we'll do this, units. Cool. So I'll go back and edit that later once I know for sure what it is going to be. Okay, so I now have a graph right here. I'm going to put this down beneath my other graph, and we can see that our process did not, in fact, linearize it. I can tell that already just looking at it, it's following a curve. But let's go ahead and fit in our error bars just in case. So we said our error bar was a constant point, constant point 0074. So 0.0074. And okay, so those are really tiny error bars. I fit a trend line, it didn't work. So my linearization didn't work. Now I need to go back and I need to relinearize the data instead. So since square rooting or to the 0.5 power didn't work, I'm going to try going to the second power. So you might think, oh man, now I have to do this all over again. Well, actually, if I just change my data up here, then we will have it all carry through down below. So all I need to do is change this from 0.5 to 2, and then I'm going to fill that down. And then I need to change this from 0.5 to 2, and I'm going to fill this down. And I'm going to change this from 0.5 to 2, and I'm going to fill this down. If you know how to use absolute cell references, you can actually have the power reference a single cell like up here, in which case you can just quickly modify it and be able to see what happens. Okay, so all my linearized times are now squared. I'm going to go back here. It's averaging those. Great. Now I'm going to scroll down. It's finding max minus min. Great. And then now I need to look at what my uncertainty is. It looks like my biggest uncertainty is oh, maybe that data didn't quite get captured. Let me double check. Squaring, squaring, squaring. Okay. Averaging, yep, that's just the biggest one. Okay. So it looks like my new uncertainty is 0.0066 or 0.007 effectively. 0.007 is what my new uncertainty is. Again, just quickly double checking my data. It's looking at the max. It's looking at the min. Cool. So 0.007 is my new error bar size. This was my graph from before. So we have error bar. It's looking pretty linear. I'm going to say 0.007 is my new constant trend line size. And we can now see that with a linear trend line, that our data actually goes through the data points and the error bars. So we've successfully linearized our data. So at this point, I want to edit my title and say this is time squared versus length for a slip of paper in free fall. And we probably would want to change that title to be a little bit more detailed to say what it's really about. So the time for a slip of paper to fall through a photo gate. So we'll say for a slip of paper to pass through a photo gate while in free fall. Just so there's a little bit more context. But we've successfully linearized our data. The next video, I'm going to walk you through doing the maximum and minimum slope so that we are able to look at the uncertainty in our trend line. So not just the uncertainty for each data point, but actually looking at the uncertainty in our trend line. That's it for this one.